Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Karyn. Hi Karyn, tell us a few words about yourself and about the tool you want to show us.
Okay, thank you, Alexei. Hello, everyone. This is Karyn here. I'm a solution engineer at CrateDB, and I'm really excited to share a bit more on our project and the latest developments, the latest features that we have added. And yeah, a little bit about me. I'm a computer scientist. I've been a dev some time ago, but now I'm more on the client-facing position. And I enjoy developing some, even though I'm not a developer anymore, I still enjoy developing some tools in Python and things like that. So yeah, I really enjoy this data world, and I'm excited to share that with you all today.
Yeah, let's see the demo.
Great. So let me start by sharing my screen with you all. And of course, it's the best place to start. So this is our repository there. This is the CrateDB repository. I wanted to start here to share a bit more on what is our database. So basically, it is a multi-model distributed database. And today I'll focus more on the first part, so the multimodal part. Unfortunately, I will not show as much on the scalable distributed part.
You'll tell us where to find more information about it, right?
Yeah, you can go ahead, search through our documentation in our website, but also here's the repository that you can have a look. If you have any contributions, they are great.
Don't forget to star. Yeah.
Yeah, the star, of course. Thank you. Don't forget to star. And yeah, and the database, something that I forgot to mention, it counts with a SQL interface. So besides those two things that I mentioned, the SQL interface, which helps you a lot getting started with this database. So what I'm going to do today to share and show you how CrateDB works, I'm going to first deploy a single node cluster, and then we're going to create a couple of tables and see how they look. I'm going to start with, I would say, a more simple example, and then we're moving, getting more complex and basically that. Okay, so let's get started. First things first, so let me start running this one here. Is just, to deploy a single node cluster on Docker. So let's run that. And
minus publish means the same as port, right?
Sorry?
It's like I saw this, you wrote minus publish in the Docker command. It's the same as -p, right? It's the port.
Yeah,
Okay.
yeah, exactly.
So this
and that's yeah, perfect. And that's actually a good comment there, because we also, depending on how you're going to use the cluster, it's also recommended to publish the 5,000 tree, the same for Postgres, because we can also use that, with some of the tools, because it's compatible. CrateDB is compatible.
Thought that P stands for port, not for publish. Okay. You even learn.
Yeah, that's why I like to write, the entire command and not only the short ones, because it's better for me to remember. But that's me. Okay, so let me get back here, and I'm going to access the admin UI. So so this is the dashboard, the admin UI, where you can look whatever you want to. You can see here on the overview, we have some information on the cluster health, and the query speed and further information. But as you know, I've just deployed it, so there's not much to see right now. But what I want you to focus now, and that's what I'm going to be using for this demo, is the console. Here we can run the SQL queries that I've prepared today, and that's where we're going to interact with the data and get the results right there. So that's what we're going to do today. So let's move to our first create table statement. So let me just paste it here. So first, we're starting with weather data. We have a couple of columns there. Nothing fancy, just like timestamp, varchar, double, and all. You can notice that the location column here is a varchar, because this is the name of the city and not, the latitude and longitude information on that. But just so you know, CrateDB also supports geotypes. So let's just create a table now. and then I'm going to insert data into that. Let me just copy this other command here so you can see how we're going to achieve that. So we are using a copy from statement, and we're just connecting to, we're going to this path here where the data is located, and then we can just, the process will happen under the hood and the data will be inserted into that table.
Is it
So let me
standard
just,
SQL syntax? Like if I execute the same on Postgres, will it work?
yeah, that's a great question. Thank you for mentioning that. So we do base ourselves on the Postgres standard when it comes to SQL. So we make sure that we're as compatible as possible. Of course, we're not 100% compatible yet. And for some cases, it doesn't make sense for us to be 100%. But yeah, that's the pattern that we will look to.
So if I execute that on Postgres, it will also work, right? This particular command.
I haven't tried,
Okay.
but I hope it does. Yeah, so I'm going to submit it. It will take a couple of seconds there. And it loaded just a little bit, yeah, 70,000 records into the table. So it was just a basic copy from. And now here we can see the table that we just created and we populated. For now, it's 0 records, but it will take some time to refresh the information, but it's already there. If you can see here, there you go. The data is already there. But what I want you to see, so basically we have the information there, the data. If you want to see without the formatting to make it look nice, it doesn't make much difference here, but I'll show on the next one, which will be clearer, the difference. But basically we have timestamp, location, as I said, it is text, no geotype needed, temperature, humidity, and you can see here there are some no columns for temperature, humidity, and others. And what we could do, let's say we have this data and we want, to fill those gaps on the data, we could run interpolation or something. So that's what we're going to do, not to replace the data, but just to show you how an interpolation could look like. So I'm going to run this query here. And before I run, I know it's a big one, so let's break it down. So we have a CTE here where we are using 2 window functions, so the lag and lead. Basically, for those who are not super familiarized with SQL, we are getting the given one time, one point in time, we're getting the closest values before and the after closest values that are not null. And then we're going to use that to calculate an average. Pretty straightforward when you look into
Are
that like
there
that.
any prerequisites on the table? Like should the timestamp be like the key or whatever?
No, there's no need. There's no need for that.
So like
Yeah.
it sorts and then does like all this thing.
Exactly.
So we don't
We
need to
do
worry
the
about it.
sorting here. We do the sorting here, and then it just goes and understands, the previous one, the next one. That's how it does. And then we're referring to the CTE here to do the calculation, and then I'm going to run so you can see the result that we get from that. So there you go. Let me see. Yeah, we do have one no here, so you can understand that this could replace this missing value in that case. So this could be quite useful when you have like time series data in general, and you have some missing data, and you want to make sure that that doesn't happen. You want to, I don't know, be creative. But the idea here is just to show that that CrateDB, it's not only like multimodal in the sense that, okay, you can storage whatever you want on CrateDB, but also it's really important for you to run queries and really get some insights out of your data when interacting with the database, right? Not only store them, and then you always have to extract it and do whatever, like run a Python code or something that would then get you some insights. You can really run a lot of functions and a lot of different queries into CrateDB. Okay, so that was the first example. You saw a pretty basic create table there, right? The next step now is a bit more complex. Now we're talking about objects. So as you can see here, we have again text, but then we have an object. A quick parenthesis, objects, well, there are different types of objects on CrateDB, and we do support some of them. But what you have to have in mind is that the object creates this kind of structure to your data. So you understand that within metrics, there are a set of metrics subcolumns to that object. So in this case, you have clicks, impressions, conversion rate, and a bit more detail on the dynamic type specifically. The dynamic name gives a little bit what this is about. But basically, within every insert, if you end up adding a new column to this object, so imagine you insert a row that contains, I don't know, conversion rate passed, something like that. It will update the definition of the table and the object, adding this new column, and then it will be indexed on the fly. That's how it works. Everything is indexed by default on CrateDB. So
Like
that's great.
nested JSON fields, right? To some
Exactly.
extent.
Yeah. And the fun part, and talking about nesting, that's also something quite interesting because you can have several levels of nesting of objects. So if you want to have other objects within objects within objects, you can do as long as it makes sense for you and your data structure, what you're trying to represent here. Yeah, you can go crazy. Okay, so that's the object.
Is this also like, is it specific to CrateDB or Postgres can also do that?
I don't know specifically. I don't know specifically for the nesting out and all those details. I don't know exactly how Postgres works with that.
But
So,
this is like
yeah,
your feature, right? Because
yeah.
like I imagine that
Mhm.
most of you mentioned that most of SQL queries that run on Postgres will also run on CrateDB. But it doesn't mean that all queries that run on CrateDB will work on Postgres, right?
No, I think
Because
it's
like
more
you
the
have a lot of
opposite.
features that Postgres does not support, right? And you support.
I think it's more the other way around. Like not everything that runs on Postgres will necessarily run on CrateDB. Yeah, it's more on the other way because as far as I remember, we do not have anything specific, like any specific queries that are not queries, sorry, functions that are only like ours. We try to, because the idea here is for us to have a distributed database with the interface, the SQL interface, so it allows you to, retrieve your data and query your data as you want. And yeah, you have quite a lot of flexibility on that. So that's the idea mainly. Oh, and I forgot to mention CrateDB was built on top of Lucene. So that's what explains, a lot of what we do and how we do. But I was going to say that on the next example because it gives more context. But anyways, so let me just continue on this one so we can wrap up and move to
It's like
to
SQL on top of Lucene, right?
Yeah, exactly.
So like
So we created the interface, the SQL.
Because like Elasticsearch has this weird query language, which I don't know, like how anyone can remember how to write these queries. Like I have to Google every single time.
Yeah.
And here, like you can use SQL to query these sort of
Exactly.
databases.
That's exactly the logic. Like you would like to use all this distributed capability, all this great stuff, but you don't need to learn a new language just to use it, You can just out of the box. And usually the idea also is that you don't have to know that it is distributed. You as an end user, you don't have to run whatever specific. You don't have to, so it will do everything under the hood. So that's the...
Because like I was comparing it with Postgres, but the more accurate comparison would be with Elasticsearch, right? Or
Yeah.
I see.
On that sense.
Yeah,
exactly. Yeah, no worries. But that's a great comment there. So yes, this last column here, that's what I wanted to talk about. This is a generated column, as you can see here. And one interesting part is this parse URL. What does it do? It is a scalar function that will basically get this landing page URL and break down into subcolumns within an object. And we're going to see how that looks, but it's just for you to understand, the logic. So that will basically parse, as the name says, the URL here. So let me just submit the query so you can, and insert the data, of course, so we can really understand what's going on with that example there. Okay. So we're going to insert, let me go to the table so we can see. We have the marketing data right there, and then I'm going to query the table. Great. So I showed before format results. If I deselect it, you can see the JSON-like look, but let's just keep like this because it's easier for us to explore. On the metrics, as I said, a couple of the subcolumns there, but the URL parts based on the landing page, let's have a look how it looks. So we have here the path, the host name, scheme, the query, the parameters, and within the parameters, this is an object within an object, as I previously mentioned. And here, inside this object, we have arrays of text. So all that crazy structure you can create and make sure, of course, it makes sense to your data and how you want to represent it here. So, okay, sounds great. So, but I know objects, they can sound a bit scary sometimes. And honestly, I don't like Postgres representation of how you access the objects. It's a bit different on Crate. So let me just select one query here so you can have a look. So this is how you can access a given subcolumn on an object. I think it's pretty straightforward for those who are like devs, the way that we access some of those subcolumns, not subcolumns, sorry, but those objects, how we can access, on dictionaries, the values within them. And the fun thing here is that, as you can see, this subcolumn is on the where clause, so we're using it to filter it out. And that's also like, this is indexed, as I said before, so everything on CrateDB by default is indexed, out of the box is indexed. If you don't want it to be indexed, then you should refer, there is this option as well. You should refer like, okay, index off, column store off, and you can, you're good to go. But then by default, everything's indexed, so you make sure that the performance is good. And you can refer to whatever of the subcolumns in there, and you can run the query. So for instance, in this case, we're looking on marketing data. We want to see campaign ID and source ID with conversion rate over 9%. So that's the idea, and we get like a set of results from that. One comment that it's important to say, we do add this limit. Usually we add limits on the admin UI for whatever queries you run. But of course, this only applies to the result that is retrieved here to the UI, because we want to limit, the resources that you're using. Imagine just loading thousands of millions of results into the UI. It could be quite heavy. But of course, this does not get propagated throughout the calculation or whatever you have to do. That's not how that works. Sometimes people do get that detail kind of mistaken, but yeah, so that's what I wanted to add there. Okay, so we've been through a simpler example. We saw a little bit of objects and how CrateDB works with them, and a bit more detail. Basically, this structure here under the hood, it is just like another column for us for CrateDB. But it's nice to have this structured way so people can really interact and create this structure for the data that makes sense for them. And that's really something that I've seen a lot of our users, how they end up using, the table definitions. Quite interesting. Okay, so I'm going to move to our third example, which is a Netflix catalog. Here, again, a lot of text going on. We do have some array of texts. And here at the bottom, and this is where I wanted to mention on the Lucene example, here we have the full text analyzer. And for those who are more familiarized with this text, I can say in the natural language processing world in general, you may be more familiarized with that. But for those who are not, just think of this as a glossary of a book. So whenever you're looking for a word, a term within a book, instead of going page by page looking for those terms, trying to identify, writing it down, there's a glossary at the end where you have the list of the terms, and then you have right next to it all the pages that refer or have some mention of that term. That's the same logic here. We have an analyzer that will process the inserted data and we'll transform that into a structure called inverted index. And this is way more performant when you're searching through text data. And that's what we have here. In this case, we're using the full text, which is a out-of-the-box analyzer, but you can create your own. I haven't tried myself, honestly, because I think there are some set of like,
creating a usual Lucene analyzer, right? And then
yeah,
say, hey, like, import it somehow.
exactly. Like you have the, how can you say? I don't remember exactly the names, but like you can define a specific character that you want to use to split the terms. And then you want to, I don't know, everything to be lowercase, and you can define all those details into the analyzer, same thing. And then, and of course, it's all done with a SQL language as well, so you can create the analyzer and
So you
all.
don't even need to write Java. Because like I remember
No.
using Lucene like 6 years ago.
Uh-huh.
Like I had to write a lot of Java for that.
No. In this case, you don't need. Yeah, no, no,
But
no.
if I want, I can, right?
Sorry?
If I want, I can, right?
Well,
Okay.
if you want, you can go ahead, check our project. You know, maybe
Uh-huh.
you find something crazy you want to add. Why not? But yeah, so let me just insert the data. I'm using the same strategy here, but of course there are other strategies to insert the data into the table there. Oh, I didn't create the table. I just showed the create table statement. Sorry for that. Then I can create the table. There you go. Now I can add the data. Great. So then I'm going to insert the Netflix data there. And for those, again, that are not familiarized with Lucene and, you know, this inverted index, I will spend a little bit more time explaining here, but this is also something that CrateDB provides. So we do use the match function there. We do have that match function there. And what is that? So basically, instead of going through every row, as I said before, looking for a specific term, you're going to use that structure that the analyzer created to search for the term that you're looking for. In this case, we have the love word there. And also that match function, it results in a score value. That means we can like shallowly saying it is just a value saying like how well that role, that information matches what you're looking for,
And we
basically.
can also put it in select, right?
Yeah, I
To
was
see
going
the
to do
score.
that next.
It's
Yeah,
like I
there you
remember
go.
when using Elasticsearch, sometimes it's useful to see the score.
Exactly. That's really useful. However, people sometimes they get a bit confused because the score, the calculation of the score also depends on the rows that you're using to calculate that. So if you use a different filterings and then you try to compare the scores of, you know, different queries with different filterings and all that, they are not necessarily comparable.
Mhm.
So that can be quite confusing. That's why sometimes I avoid showing score, but I think it's useful in this case. So let me just run the query and then you see the score there. And we can even like try to guess given the full text analyzer. But for instance, here on the first row, we're looking for love and we can see that there were like 1, 2, and I think there's another one, 3 love comparing to the second one, which has only 1. So it's like 2 actually, there's the last one. So that can be, you know, a reason for this one to be a bit better than the second one. But yeah, this is quite, I think it's quite interesting. However, of course, like this approach does not take into account the meaning of the love, you know, when you're talking about this one, is this like, I don't know, more psychological, is this whatever? It doesn't take into account that. And that's why recently we added the support to flow vectors. So you can use embeddings and capture a bit more, you know, other levels of concepts, right? And I'm going to show that next because I wanted to create, but this one is not as fun because I didn't manage to get like a bigger example. But let's see this. So I'm going to create another table. This is way simpler, and I'm just going to use embeddings there. It is a float vector with 4 positions, so it's not as big, but we do currently support up to 2048, if I'm not mistaken. So that's already something. So you can start working on that. So let me just create a table. And then I'm going to insert some really basic example there, which is a couple of expressions here as the text. And then we have the embeddings. For those who are not, I'm not super familiarized with embeddings as well, but from my understanding, the embeddings here, we have like different positions, different positions on the vector, and each of the positions they have like, they refer to a concept. So you have this value that says how close or how far you are from that concept, that given line, so exploring the cosmos, how far that is from that concept, that specific concept. That's really interesting, honestly. I've been trying to learn more on that topic recently. So let me just insert those, and then we can just run the last query that I have prepared for today, which is we have a KNN match. And again, that's something that I think it's quite interesting for CrateDB, because our team, when we talk, okay, let's support this new data type and let's do whatever, we never just add the data type and say like, yeah, it will be there. And then if people want to do whatever, well, maybe next time or whatever. No, we try with the new, this float vector data type, when we added that, we thought, well, KNN match makes complete sense. First, you have that. If I'm not mistaken, it is in Lucine's project. So like it's already there. We just make sure it's available for everyone. Straightforward. In this case, what we're going to do, we're performing a KNN, K nearest neighbor match on the embedding column. And we have this specific, I don't know, expression we chose, and we're looking for the two nearest neighbors on this case. However, one comment, you're going to see four results, 4 rows below, and that's because we calculate this number is based on each shard of the table. I can talk more about the sharding and partitioning later, but it's just for you to understand that we calculate this like on our smaller part, since it is distributed, we have the shards. So we calculate that on that level, and then we propagate, but we propagate the result. We don't then recalculate. It's just how we currently do. So let me submit the query so you can see what I'm talking about.
Like if we
So
really need 2, we can just add limit 2 at the end, right?
yeah, but then the problem, yeah, you only have 2, but then the problem is that we are not going to be comparing the results among them, among the shards. So we don't necessarily know like which are the really closest, the 2 closest ones. So, but you can do that yourself, right? Like you have the results there, you can have a look and check if that makes sense. And here, that's the result, the score. The logic is pretty similar there with the match that I explained there before. Because here is a bit clearer because we're seeing the vectors, the representation of the vectors. So it makes more sense, in our heads how to calculate these vectors, the ones that I inserted previously. I think it's here. So the ones that I inserted recently, and then the one that I was selecting. So you can compare them and yeah, have some fun. So basically that's what I wanted to share as a multi-model database. I wanted to share a bit on the data types available, how you can query them. I haven't covered the distributed nature of CrateDB, which I think it's one of, you would need at least another session because it's quite interesting. But as you know, a lot of Lucene already, so you know about the indexes and the sharding and all that. So yeah, that's the logic there.
I
That's something
assume
that
it's similar to Solr and Elasticsearch, right? The way you do distributed thing.
Yeah, we do that. Yeah, that's pretty similar. And you can also on the admin UI, you can check your cluster and the shards distribution. But since I have a single node, so here it's a bit boring. But if I had more nodes, you could see here and how they look there. And on the shards, in this case, everyone is on the same node. But if I had more nodes, you will see how the shards, the smaller, for those who doesn't know, the shards are like small pieces of the table, and they get distributed around the nodes to make sure that you are getting the most out of parallel processing. And you will see them distributed here, but in this case, yeah, just one node, not as fun.
I'll ask you a few questions, like just two, and then
Okay.
try to answer them quickly, and then
Okay.
yeah. Okay, yeah, thanks. How can people contribute to CrateDB?
Okay, so let me go. Yeah, you see the project here. I would say anyone just go ahead. If you have a good idea, something that you want to discuss, yeah, go ahead with the issues or pull requests. You're more than welcome to add your contributions to our repository.
And I guess you need to know Java for that, right?
Yeah.
Just like it's right?
Yeah,
Okay,
but
and yeah,
sorry, we do have other projects that support CrateDB, so like extra features that we create surrounding it. One of the most recent is Crate Toolkit, and it's in Python in case you wanna, you're more familiar with Python. So give it
so
a
you
look.
need to go to your organization and then see what kind of projects are there, right?
Yeah, exactly. There are many.
Uh-huh. Do you have any advice to anyone who's watching this?
Oh, that's a good question. So I would say just in general, like if you mean like specific to the technology or just in general?
Life advice, general advice, technology
Okay.
advice.
I think so. Like technology can be a bit scary sometimes, but don't be afraid of that and give your best shot.
Okay. Yeah. Thank you. Amazing demo. And I'm pretty sure many of us will like to play with Crate. Thanks a lot.
Thank you. Thank you for your time.